Hello everyone. Our lesson today is about electromagnetic waves. Electromagnetic waves, we will take one example of it, the light waves. So, light waves belong to a whole family called electromagnetic waves. What's that mean? The electromagnetic waves, it has different examples of it, or different, it consists of many types of waves. One of these examples, it's light wave or light waves. The family of electromagnetic waves, okay, they have some features in common. These features are, firstly, they can travel through vacuum. What do we mean by this? It means, or we mean that this kind of waves, it can transfer or it can travel through an empty space. If you remember when we talked about sound waves, okay, we said sound waves to travel, it needs a medium, it needs a particles to travel through it. But here in light or in electromagnetic waves in general, here there is no need for medium, there is no need for particles to carry the waves. These waves, it can travel through a vacuum, for example, space. Then they travel through vacuum at speed of 300,000 kilometers per second, okay, which is we call it speed of light. So the speed of electromagnetic waves, okay, it's what? It's 300,000 kilometers per second. Then they are transverse waves. In Unit 6, when we talked about waves, we said we have two main types of waves, transverse and longitudinal waves. So the electromagnetic waves, it belong, or it's an example of what? It's an example of transverse wave. What do you mean by transverse wave? Okay, transverse waves, the oscillations. What do you mean by oscillation? This is the oscillation, okay, moving up and down, okay. The oscillations or the vibrations are at right angles to the direction of travel. So here the wave, now it's traveling by this direction. As you can see here, it's the arrow, it shows the direction of traveling. The oscillations here are what? Are at right angle to the direction of travel. Then they transfer energy. What do you mean by they transfer energy? It means when they are traveling, they are carrying energy with it. So a source loses energy when it radiates electromagnetic waves. A material gain energy when it absorbs them. If we want to take an example to explain this point, we will take the sun as an example. Sun, it radiates, it gives energy, it gives waves, which is light, okay. So when it's giving light, so this light, it's what? It's energy. This energy now, it's traveling from sun until, for example, it hit any object. For example, let's say you will have solar panel. So a light will travel from sun, and while it's traveling, it's carrying energy, which is light energy. When this light energy it hit, or it will be absorbed by solar panel, now solar panel, what? It will gain energy. From where it get this energy? It got it from the sun. So how this energy traveled? It traveled through the light waves, or through the electromagnetic waves. The electromagnetic spectrum. The word spectrum here, it means a group of things together, okay. For example, if you remember, when we talked about light, when it passed through a prism. When a light it passed through prism, after it passed through the prism, what will happen? The light will be like it will form many colors. Okay, all the colors. First, it enter as one color, which is like white. Then it exit as different colors. We call them spectrum. The same thing it's here with the electromagnetic waves. The electromagnetic waves, okay, the full range of electromagnetic waves is called electromagnetic spectrum. What do you mean by that? By it, if you will go to the next page, you will see here what do we have. As you can see, here all of these are examples of electromagnetic waves. An example, radio waves. And radio waves, it has these types: long, medium, short, VUHF, microwaves. Then you have infrared, light, ultraviolet, X-ray, gamma rays. Okay, so all of these are examples of electromagnetic waves. So these, all of these rays together, we call them electromagnetic spectrum. Okay, the electromagnetic spectrum. As you can see, each wave, it has a frequency and it has a specific wavelength. Okay, so long, medium, and so on, and uses of each kind of ray. Where electromagnetic waves come from? Electromagnetic waves, it comes from atoms. But how? As we know, all matter is made of atoms. And as you studied in grade 7 and grade 8 about the structure of atom, you know that the atom, it consists of electrons, okay, and it consists of a nucleus, which contains the protons. Now, electrons are negatively charged. Nucleus, it's positively charged because of the protons. So, also we talked about in grade 9, we talked about conductors, like for example metals. Example, let's say copper wire. A wire that is made up of copper, when electricity it passes through it, what's that mean? It means the electrons are transferring, the electrons are moving. So what will happen here? When an electron can escape from the atom, okay, for example here, electric current passes through a wire. Now, how this is related to electromagnetic waves? Electromagnetic waves are emitted or sent out whenever charged particles oscillate. So when we say it in, for example, let's take an example, bulb. When electricity it passes through the bulb, what will happen? Some vibrations, okay? The vibrating atoms in a hot glowing bulb filament emit infrared and light. Okay, again, when electricity it passes through the bulb, what will happen? The filament of the bulb, the atoms that it makes the filament, it will start vibrating. What do you mean by vibrating? It means going up and down. So vibrations here, going up and down, it means transverse waves. So because it's transverse waves, so it's what? It's electromagnetic waves. Then here we said the bulb, it will give light and infrared waves. But why exactly this one? Or why light, or why infrared? Why not the other examples of electromagnetic waves? Here it depends on the wavelength. What do you mean by wavelength? Again, this is wavelength. length. Okay, if we will go to the next page, you will see here what do we have. The examples, the different examples of electromagnetic waves, they differ by their wavelength. See, each example, it has a specific wavelength. Now, what or why we have different wavelength? Why we have different wavelength? It's because of the energy. For example, the higher the frequency of oscillation, or the greater the energy change, the shorter the wavelength will be. Okay, so when the energy, the changing in energy, it's greater, so the wavelength, it will be shorter. Questions. Question number 1. Give 3 properties or features common to all electromagnetic waves. As we mentioned here at the beginning of the lesson, here are the common features of electromagnetic waves. Firstly, all of them, they can travel in vacuum. Their speed is 300,000 kilometers per second. They are transverse waves, and also they can transfer energy. Question number 2. Put the following in order of wavelength, starting with the longest. Okay, so ultraviolet, X-rays, red light, violet light, microwaves, and infrared. We should put this electromagnetic waves, or these examples of waves, in order depending on their wavelength. We will start from the longest one to the shortest one. So to solve question number 2, let's go to the next page. In the next page, okay, so we will start firstly from microwaves. Okay, number 1, microwaves, then infrared, then red light. Okay, here is the red light, the first one, then violet, then ultraviolet. After that, we will have X-ray. Wavelength, okay, here we will it's the longest one, okay, to the shortest one. So if you just look at this drawing, okay, here you can understand that the wavelength here, the wavelength is the distance from this point to this point. So if you will compare this point, the distance of this point, this distance, with distances here, of course here it's more. Question number 3. Name a type of electromagnetic radiation that, firstly, is visible to the eye. Okay, from all of this, which one is visible to eye? Which one we can see it? Let's take an example. Can you see the, for example, can you see the microwaves? No. Can you see the infrared? No. Can you see the X-ray? No. The only light that is visible for our eyes, okay, it's light, okay, here as it's written, only type of radiation visible to the eye. B. Is emitted by hot objects. The answer is infrared, as we explained here. Okay, we said when a hot glowing bulb emit infrared. Okay, so from where, what kind of type? Okay, it's emitted by a hot object. It's the uh, infrared. C is diffracted by hills. The answer, if we will go as it's given here, it says you need to go to the next topic. So the question, it says it is diffracted by hills. So here it's the answer, the radio waves. So here radio waves of long and medium wave diffract or bend round hills. Okay, here is the hill and the waves here, as you can see what it's happening, it's diffracting or it's bending round the hill. D, can cause fluorescence. The answer for this, it's ultraviolet. Okay, so ultraviolet, okay, here it causes tanning and also it causes fluorescence. So here, as we said, each type of electromagnetic radiation and the wavelength of it and for what do we use it. Okay, microwaves, for example, mobile phones, TV, communications, uh, infrared, okay, security alarms, and X-ray. We use it used for X-ray photography, causes also fluorescence, causes cancer. Uh, E is used for radar. Okay, again you will go to here. Which one it's used for radar? Okay, microwaves. Then the last one, can pass through dense metals. Can pass through dense metal. So the answer here is, you can say either X-ray or gamma rays. Okay, and it's used for sterilizing medical equipment. Question number 4. A VHF radio station emits radio waves at a frequency of 100 megahertz. Question says, what is the frequency in hertz? Here, they gave us the frequency in megahertz. You need to convert it into hertz. So here what we are doing, we will convert from a big unit into small unit. So as we mentioned before, always if you want to convert from big to small, what you will do, you will multiply. But you will multiply by how much? If you will come here, it says 1 million hertz equal to 1 megahertz. So here what we will do, uh, we will multiply 100 times 1 million. Okay, the answer will be 100 123 123 HZ. B, what is the wavelength? Okay, speed of radio wave, it's 3 times 10 to the power of 8. Also here, if we want to find the wavelength, we can use this equation. Speed equal to frequency times wavelength. Speed, we have it. It's 3 times 10 to the power of 8. Or what's the meaning of 8 power of 8? It means 8 zeros times equals to frequency. Frequency we just found it here, which is this number. Here is the frequency. Okay, you will add times wavelength. We want to find it. B. What is the wavelength? Speed of radio wave equal to 3 times 10 to the power of 8. To solve this question, here we will use this equation. The equation that it says speed equal to frequency times wavelength. So, first step, you will write the equation. Then you will replace the words with numbers. Here, instead of speed, you will write 300 million. Maybe you'll ask why, from where this 300 million comes. It's this one. 3 times 10 to the power of 8. 10 to the power of 8, it means 8 zeros. So instead of writing 10 to the power of 8, we will write 8 zeros. Then frequency we just found it here in question number 1. Also, it's 100 million times wavelength. Okay, by rearranging the equation, you will get wavelength equal to 300 million over 100 million. So the wavelength, it's 3 meters. C. What is the wavelength of radio waves from a long wave transmitter broadcasting at a frequency of 200 kilohertz? To solve this question, also here, what do we have? We have radio waves. Okay, they are asking us to find also the wavelength. To find the wavelength, we will use the same equation, speed equal to frequency times wavelength. Now, speed equal to frequency times wavelength. Instead of speed, we will write 300 million. If you will ask why 300 million, because also we took this number from here, from B. It says speed of radio wave. It's what? It's 300 millions. Then frequency. Frequency here, the number it's given with kilohertz, and as you can see here, frequency, it should be with hertz. So here, what we will do, we will just convert the kilohertz into hertz. So we convert 200 kilohertz into hertz. Now it's 200,000. Now wavelength, it's equal to 300 million over 200,000. The answer is 1,500 meters. So, dear students, this was everything for this lesson. Your task for this lesson is to solve the questions in the workbook. Again, when you will finish watching this video, write your name. If you still have any questions, any concerns about the topic, please don't hesitate to text me. Thank you and have a good day.